Just always focus on the machine elements.
Alright.
Ready?
Yeah.
All right. So here's our light box for our photoelastic truss analyzer. It pretty much provides a light source and has a bunch of LEDs and aluminum for heat dissipation. We also have a linear polarizer in front of this to polarize the light that will be coming through, and we're going to be using that to analyze the stresses in truss structures. So as you can see over here, we have many different parts and pieces. These let you assemble any sort of truss structure that you'd ever want. So these are all the components. Here are some supplementary components that we use to frame it on our framing panel. And I'll show you guys that in a little bit. So let me move this over. So first things first, we're going to actually need to assemble a truss structure. So I took out a bunch of pieces here. These are primarily what we're going to be using to assemble some sort of truss structure. Let me actually replace these with a more appropriate piece from our box. And there's different pieces that you might want to use. And again, these are also color-coded for the type they are. Due to the nature of the analyzer, you need to have specific orientations. So these red ones are always horizontal and vertical, while these blue ones are actually they can be oriented diagonally. This is how the orientation would look like on the board. So let me assemble this real quick. The assembling process is quite easy. It's just that all these pieces are cut to size. There is a size chart to look at if you want to design your own. Now, I'm going to be designing this arc bridge with a single 0-member structure in between. So it's going to look like something like this. And because of the nature, we're only looking at 2D elements, we want to make sure there's no z-axis forces, so we're going to double up everything. So nothing's off-center. So we're going to put this and turn this. Pretty much as soon as you've gotten these parts down, you can just lay them down on top. And now we just pop in the pins. There are several metal steel pins that we can use. So let's start with one end and move to the other. So as you can see, it's just simply as popping them in there. Sometimes you might need to lift them up. And there we go. So make sure that the pin goes all the way in. And again, a mallet might be a good thing to use to put these in there. Sometimes they're a bit stiff, but they should be cut to size. The bores are designed to be fitted into here. And there's two. And here are the others. So that's one pin. This is a bit stiffer than normal, but that's alright. We got one in. Now let's work alright. Put one through the center. And we can just lay this one on top. Pop it in there. Got 2 out of 4 of our pins. I'm probably going to leave the top one for last, just it's the most complex, or has the most connections. Actually, one thing before we do that, we actually would need to put our pin joiner where we're going to be connecting the structure to the base, so one of these pieces. Just I like popping it on one side and putting that up here. And we're going to slowly make sure like that. So this is a pin joiner. This is how we're going to be connecting it to the frame and how we're going to be securing it. So we're going to have a roller joint on one end and a pin connection on one. So this will control the loading forces. So our bridge is static. And so we got that done. Now with the last pin. Oh, whoops, looks like this one slipped out. And the last piece needs to go up there. And this one might take a little bit of finickiness. Alright, as long as you got it all aligned. And again, they're designed to be fully aligned on. So the sizes are all cut to the exact size that we want them to. So now the only thing is just aligning it. So here, like simple as that. So a few pins. Now that we got this structure fully assembled, just make sure nothing's coming out. And try to put the pins towards the center of the structure. so that they're kind of in the center. And there's our bridge. There's our bridge truss structure. So, and you can add more pins to places just, yeah, because again, we're going to be adding forces on these pins. So if you want to take a different piece, such as this one, or something with a bit more holes in it, we could apply stresses, points of force anywhere else. So even though these pins wouldn't have, these connections wouldn't have anything connected to them, you could later add forces to these. But for this example, we're going to be using something like this and just adding a simple force, showing a zero member in action. So now the mounting comes into place. So let me move the light box out of the way for a second. The mounting process is also somewhat similar. We use pins to pretty much connect this structure onto our frame. Here is our frame. This is what we're going to be using to exert forces and various to hold our structure in place. So again, these pieces fit in pretty neatly. The holes should all align. They are all an inch apart. So if you can imagine like a grid mesh of connection points, that's how we kind of assemble it. So as soon as you attach one of the sides, you can just pop in a pin to make sure it stays in there. Again, the aligning process, and that's in there. Now we have one pin connection. We're going to be using a roller connection now. So we're going to put this roller right here at this end, and we're going to just pop a pin in there to make sure it doesn't move around too much. And now our bridge, we've completely framed our connection. The last thing that we have to do is take one of our force exerting screws. I am going to take this large one actually. This one's actually maybe a bit overkill, but we're going to plug in, as you can see, there's two guiding rails on this frame piece. We insert our screws at the end. In fact, I probably should, this is probably, since we're exerting the force from the bottom, pulling the structure down, we're going to want to take out our roller just for a second and insert this, insert the force screw in. So it's pretty much just aligning them, and it will slide into place as soon as you got it in. Also, this one, you might want to unscrew them. There we go. And that is in. Now that this is in, you can actually stop it at the place that you want to exert force, tighten up these screws, and that should hold it into place temporarily, just by friction. And we'll pop our roller back in. And this shouldn't move anymore. Now, you might want to also move the force screw all the way down. So now that this force screw is out of the way, we can actually have our frame structure. And there's our complete setup for this example. You can add more force screws, less pieces, and just change your setup. But again, it's usually just based on preference or what example we're going to be using. And we will be, and as soon as it's all done, you can drop this into place on our stand here. The light box will be in the back. This will be in the front. In fact, I'll show you I'll take it all apart and I'll show you how each element is fitted together later on the frame, on this stand. So as soon as it's all in place, we just need to make sure that all the pieces are lined up and nothing's coming out. And there we go. There we are. Alright, so now our structure's in place. Now the last thing is to attach the wires from our force screw. Now I'm going to loosen this nut right here to drag this a little up so that we can get this connected. And I'm going to loosen it. Alright, and we still need to bring it up a bit more. And so these little wires will go on each side of this pin that we want to exert force on. So, and we're choosing to do it on these two for now. And now that's over. Now you can tighten up the nut. And it should exert, and it just tighten until it's basically you can tighten no more by hand. We're going to be using the screw, this handle right here to actually pull this wire down, exerting a force downwards just to see those forces in action. So now the setup is complete. I've tightened the screw, or I've tightened the nut as much as I can, and I'm going to insert the final element of the machine, which is just another polarizing screen. Push this back a bit and insert the screen in front, like so. It should be able to sit in normally. And now we can turn on the machine. And as you can see already, this is the standard there's no strain on the structure at all right now. You can see it should be mainly clear bluish, some might be yellow. In fact, that might be actually something from the cutting process. When we cut these polycarbonate pieces out, that there was some residual strain left in them. But for the most sake, this looks pretty normal. This is pretty much how much we have no stress, and I'll show you what it looks like under stress. So now we're going to use our screw to exert some forces onto our structure. So I was loosening it, so let me again pull using this screw. It's going to be pulling this cable that I have attached down, which is going to cause, as you can see already, there's some strains already exerted, obviously on these arcs. But you can notice that there's a zero member right here. Of course, that's from we know from statics that there's no stress or strain forces passing through that. In fact, the arc is the primary points where we're going to see a lot of strain. And this is technically not showing stress, it's showing strain, and it's technically deforming on a very small scale. So we're actually exerting some deformities here. But it's all elastic. When we loosen it, you can see that the strain goes away. So this is all elastic deformation. And we can use this to observe different stress systems and different truss structures. Again, I showed you all the modular pieces that we can add to this. We can have any sort of truss structure that we'd want. In fact, I'll show you one more just to be safe. But this is our unique, I like to call this the rainbow example, because we get to see a lot of different strains right here. You can actually even see, like, on the pins there's strain already. That this pin is exerting strain around the board as well. And we can actually use this for different examples. And you can actually see the more I put it under stress, the more I pull this screw out. Eventually I can pull it out to quite a big degree, and you might get plastic deformation. But again, this is how much the model is supposed to go. So you can actually see a lot of different colors. And this is also showing you strain. The bands, the closer the bands are together, show you the more and more strain. The colors themselves are not indicative of anything in particular. It's more about the cycling through colors. The more colors you see in a line, or the closer they are together, the more strain you're seeing. So that's primarily what we're using this to observe. This can be easily used in a classroom to demonstrate zero members, any sort of truss principles, two force members, any sort of example like that can be used by this system. And that's one of them. So this is pretty much the machine, the 4-screw. And again, like, you can insert screws on top to add forces in the upwards direction. You can also insert screws on the side to exert forces on the side. Again, this is designed to be very modular. So any example you can kind of think of. We also have an example of the cantilever beam. In fact, let me show you right here. This one's kind of quite easy to assemble, as long as I have the right parts. A cantilever structure, let's just use this one. You can use something like this in our mounting block. Push it in, pop in a pin, and let me make sure it's aligned. There we go. There we go. This is a cantilever beam. I'm just going to take out all these elements real quick. Insert this to show you just a real easy cantilever problem as well. And of course the light gets super bright when you remove the strains. In fact, theoretically, if you're looking at it from the front, there should be no light passing between the two polarized films. In fact, the only light that should be passing, if you're looking at it from directly in front, which, can you do that real quick? Can you look at the bridge structure? You can actually observe that there's no light. There should be no light coming out of, bring the camera a little down, like directly at this point. If you look straight like that, like so, you should see no light coming off of the rest of the elements. Only the bridge should be showing light. So yeah. Anyways, that is how the machine works. And this basically I'd assemble it the same way. I would basically just mount this along the side, and again there's pin points on the side, and that would basically allow me to do a cantilever problem. So there's just a bunch of different structures you can use. We also have extension modules, so you can extend this out one space. Say for example you want to do a vertical problem. Again, there are a few different pieces that we have. We have pin joiners, cantilever beams, we have rollers, and that's primarily what it's used for. So these are all the elements of it. Now let me take it apart. So here's the screen, just take apart the screen. The frame will come out as well, like we showed before, and the light box is its own element as well. And the stand has pretty much slots in for all those elements to be fitted in. And that's the machine. This is the Photoelastic truss analyzer. And yeah, and that's how you use it.